Okay, let's continue with chapter 5, equilibrium of rigid bodies. So let's try to solve this problem, illustrative problem. Find the reactions at the supports of the beam loaded as shown. So given na yung answers natin. Okay, so first of course is we need to identify kung anong klaseng support meron yung beam natin. Ano? So take note na yung equation natin tatlong equations lang. So summation of forces along x is equal to 0, summation of forces along y is also equal to 0, and summation of moments should be equal to 0. So yun ang i-apply natin. Okay? So, dapat yung number of unknowns natin, therefore, dapat ay tatlo lang din. No? Since you only have three equations of conditions of equilibrium, no? For 2 dimensions, of course. Now, kapag nag-exceed yung number of unknowns sa number of equations natin, magkakaproblema tayo. No? Although, may mga ganun, most of the structures naman, ganun talaga, mas marami yung unknown na reactions compared to the number of equations. So, yung mga complex structures natin. But sa subject natin, statics of rigid bodies, we're going to deal with determinate structures, which means that yung mga problems na ibibigay na isosolve natin ay yung mga structures natin ay meron lang 3 na unknowns, no? So yung indeterminate na structures, yung mas marami yung unknown na reactions compared dun sa conditions of equilibrium, that would be different subject na. Okay. So sa statics of rigid bodies, we are going to deal with determinate structures only. Okay. So first, we need to identify yung ating supports. So the beam is supported by ito sa point A, itong support naman ito sa point D. So, what is point A? What is point D? Anong supports yan? So, at point A, meron tayong hinge support. Hinge or pin. So, ilang unknowns ano yung reaction kapag hinge or pin? Dalawa, isang vertical at isang horizontal reaction. Kapag ito naman point D, roller. Roller yung point D. So, kapag roller, isa lang yung ating reaction. So let's draw the free body diagram. Okay. So this would be our free body diagram. So yung support natin, palitan na lang natin ng forces. So this is y, sorry. Vertical pala yun. And this is RAX. Yung dalawa kapag hinge, dalawa. Isang vertical, isang horizontal. So you can assume any direction naman. Okay. You can assume RAY to be upwards. Assume RAX to be to the right. Okay. Okay lang na mag-assume tayo ng any direction. Kasi sa final answer, maalaman natin kung tama yung assumption natin, initial assumption natin, yung ng direction ng reactions. Kapag mali, yung initial assumption natin ng reactions, then sasabihin yan din sa answer natin later on, negative siya. Yung pag negative, ibig sabihin mali yung initial assumption natin na reaction. Although the value would be the same, magkakaroon lang ng negative sign, no? Because of the wrong assumption. Okay, which we can easily correct naman, no? Then sa point D, roller, let's say RD. So pag roller, isa lang. And don't forget, of course, sa pag-drawing ng free body diagram, don't forget yung loading. Ayan. So this is 20. Okay. This is 1 meter. So this would be our FPD. We are solving for the reactions. So again, we have three equations or conditions of equilibrium. To solve for the reactions, okay, usually, ano yung unang equation natin para ma-solve yung reactions natin? We apply the principle of moments. So we summate moments at saan tayo mag-summate ng moments. So summation of moments, we can summate moments at any point along the structure, along the beam. Pero para to simplify yung analysis natin, so mag-summate tayo ng moments where two or more unknown forces are located. So we summate moments where two or more unknown forces are located. No? In this case, that is point A. Okay. Point A, meron tayong two unknown na forces dyan. That's RA, X, and R. Bakit doon? Bakit sa point A? Tayo magsasamate ng moments. No? Bakit nga ba doon? Para ma-eliminate na yung moment ng RAY tsaka RAX. So, at point A, wala nang moment yung RAY, wala na ring moment yung RAX kasi wala silang moment arm. No? So, kasi dyan mismo, dito mismo sa point na ito, tayo magmo-moment. So, ang may moment lang would be itong reaction sa may D, itong mga forces no, along the beam. Okay? Since distributed normal loads ito, kailangan mo nating i-solve yung resultant. So, i-divide na lang natin into two. Dalawa na lang. Isang triangular loading tsaka isang rectangular loading. Okay, so this is, let's say, R1, R2. Subukan natin yung R1 and R2. Okay. So, yan. Although, pwede naman diretso sa equation natin, pero para mas detalyado, para maintindihan natin agad, mas madali maintindihan siguro, ano, kapag ikukunin muna natin yung resultant ng dalawang distributed normal loads. So, R1 is equal to yung area ng rectangular loading natin. So, that is equivalent to 20 kilonewton per meter times, that's the height, ano, times the length, that is 3 plus 1, that is 4 meters. So that is R1. R2 is the area ng triangular load natin. So that is equivalent to 1/2. So remember, yung 80, ito yung 80 natin, yung buong yan. So since nasama na yan ito sa rectangular load, ano na ito? Intensity ng triangular load natin. So that is 80 minus 20, so that is 60 kilonewtons per meter. We have 60 kilonewtons per meter times yung base natin na 3 meters. So what is R1 and what is R2? So obviously R1 is 4 times 20. That is 80 kilonewtons. And R2 is equal to, so 1/2 times 60 times 3, so that is 90 kilonewtons. Okay. And of course, since we are summating moments at A, we need to know yung perpendicular distance between o yung moment arm ng R1 relative to point A and R2 relative to point A. So, anong distance ito? R1 from A, and then we also have R2 from A. So, R1 natin, so 4 plus 3 divided by 2, so that is 2 meters. And this distance, R2 from A, okay. So, itong distance na to, ito lang yung triangle natin, ano. So, this is 2/3 of 3. So, 2/3 of 3 is 2 meters plus 1 meter. So, that is 3 meters. Okay. We have discussed this before sa previous chapter, previous topic natin. Okay. So, okay na. So, we can now summate moments at A. So, again, bakit sa point A? Because nandun yung dalawang unknown forces natin. So, summation of moments at A is equal to 0. So, ang ating sign convention, clockwise moments positive. So, ano yung mga may moments sa A? We have RD. RD creates a counterclockwise moment at A. So, negative RD times yung moment arm ng RD. So, that's 3 plus 1 plus 1. So, that is 5 meters. Okay. Ano pa ba? Yung moment ng R1 about A. So, R1 creates a clockwise moment about A. So, R1 kanina is, so, plus 80 times moment arm ng R1 relative to point A. That is 2 meters. Plus ano kasi clockwise yung moment ng R2 about A. So, clockwise. So, R2 is 90 kilonewtons times moment arm niya is 3 meters. That should be equal to 0. So, we have one unknown in the equation, and that is RD. RD is equal to, or that is dV here. Dito sa may problem, dV. So, RD is equal to 86 kilonewtons. Okay? So, that is RD. Next naman, solve natin yung RAY and RAX. So, to solve for RAY and RAX, we still have two other equations, ano? So, summation of forces along X is equal to 0. So, lahat ng horizontal forces i-add natin. Okay? So, ano yung mga horizontal forces? We have RAX. Ano pa? Wala na. So, RAX is equal to 0. So, walang RAX. And then, lastly, para masolve na yung RAY, we can summate forces along the vertical direction Y. So, upward forces positive. Okay, so RAY, we have assumed it to be upwards. So, RAY. And then we have R1 na downwards. R1 is so minus 80. We have R2 na downwards. So, minus 90. Meron pa ba? Wala na. So, equate that to 0. So, RAY is equal to okay, I'm sorry, meron pa pala. R1, R2. Meron pa pala yung RD. Ayan. So, we forgot to include yung RD. RD is upward. So, plus, nasolve kanina, 86 kilonewtons. Okay? And then equate that to 0. So, RAY is equal to 84 kilonewtons. Okay, so that's it. Yun na yung reaction natin. So, ang reactions dun sa hinge or pin support, RAX, RAY. And we have the roller support at D na 86 kilonewtons. Okay? Next, illustrative problem. Okay, next problem. Determine the normal reactions at the roller support at A and the horizontal and vertical components of at pin B for equilibrium of the member. So, sinabi naman na problem kung anong klaseng anong klaseng support meron sa point A and point B. So, at A roller daw. So, roller, which means ito na yung gawin nating free body diagram, no? So, ilagay ko na lang dito yung mga reactions natin. So, ito, at A, since roller yan, perpendicular, no? This is, let's say, RA. So, you can assume any direction naman, yung RA. So, upwards yung inassume ko. And then, sa B, hinge or pin. Kapag hinge or pin, meron tayong vertical and horizontal. Okay. So this is RBX, RBY. So we are solving for these three reactions. Okay. And we have itong 6 kilonewtons dito. So I think it would be more convenient if we convert that into its components along X and Y axis. So this is F Y and this is F X. Okay? So ayan. And don't forget yung angle. So kung 60 degrees yung inclination yan, this is also 60 degrees. Ayan. And this is 30 degrees. Okay, anyway, one angle is enough. Okay, next is to solve for the reaction. Apply now the conditions of equilibrium. So we have three equations again. Okay, so we normally start with the summation of moments, although that's not always the case, you know. So summation of moments, where do we summate moments? We summate moments where two or more unknown forces are located. So saang point yan or saang part yan ng frame natin? Okay. Saan yung may two or more unknown forces? That would be at point B. Yan. So at point B, unknown yung RBY and RBX. Dito, ma-solve natin yung Fx and Fy. Hindi yun unknown na. You can solve it because given naman yung magnitude ng force and then the angle. So ang unknown natin dito is RA, RBX, and RBY. Okay. So we summate moments where two or more unknown forces are located, and that is joint B or point B. So summation of moments at B is equal to 0. Clockwise moments, positive. Ayan. So ano yung mga forces na may moments at B? Of course, yung unknown force natin na RA. So RA creates a clockwise moment about B, so that is positive. RA times ano? Ang moment arm ng RA relative to point B. So itong distance na to. This distance, anong distance ito? So it is 0.6 hanggang dito na kwan, that is 0.6 plus 0.6, so that is 1.2, ano? 1.2 meters ito. So we are trying to identify yung moment arm ng RA relative to point B. So how do you solve for this distance? Itong distance na yan. Ito. So this distance is equal to, anong distance ito? So that is 0.4 meters, tapos 0.8. So adjacent side ito, given yung adjacent side natin, so you can imagine yung triangle. So we draw natin. So this is 60 degrees. Ito, we are dealing with this triangle. And this is 0.8 plus 0.4, that is 1.2. Okay, so that is 1.2 meters, and we are solving for this side of the triangle. So that is 1.2 cosine of 60 degrees. Okay. So 1.2 cosine of 60 degrees that is 0.6 meters. Okay. So 1.2 cosine of 60 is 0.6 ba? Yeah, 0.6 meters. So ang moment arm ng RA relative to point B is 1.2 plus 0.6 meters. Ayan. Okay, next. So that's the moment of RA relative to point B or about point B. And then we also have the moment of the 10 kilonewton force about point B. Moment ng 10 kilonewton force about point B. Okay. So that's counterclockwise. Counterclockwise yung rotation caused by the 10 kilonewton force. So that is negative 10 times its moment arm about B. So that's 0.6 plus 0.6. 0.6 yan, plus 0.6. So 0.6, or that is 1.2 obviously. And then moment ng 6 kilonewton force about point B. Although given na pala yung moment arm, wala pa. There's no need pala to resolve this into two components. No? Although you can also do that. Okay. Pero, hindi ko napansin. Given na pala tong distance na yan, that's exactly the moment arm of the 6 kilonewton force from point B. Ito na. But we need the components later on when we summate the moments or summate forces along the x and y directions. Okay. Or axis, I should say. So, yung moment ng 6 kilonewton force about B, it creates a counterclockwise moment. Yung direction niya is counterclockwise. Okay, about B. So, that should be subtractive. So, minus 6 times 0.4. Yun na yung perpendicular distance. Meters. So, okay. So, okay na. Wala na yatang ibang forces. Okay. So, that's it. Equate natin sa 0. So, we have one unknown in the equation, and that is RA. So, RA is equal to 8 kilo newtons. So, that is RA. RA is equal to 8 kilonewtons. Okay. Alright. Next is to solve now for the other two reactions, RBX and RBY. So, we can use the other two conditions. So, summation of forces along x-axis is equal to 0. Forces to the right are positive. So, we have assumed RBX to be directed to the right. So, positive yung RBX natin. And Fx here, yung component ng 6 kilonewton force along the x-axis is directed to the left. So, minus dapat yan. Fx, which is 6 sine of 60. Meron pa bang ibang other horizontal forces? So, wala na. Equate na natin yan sa 0. So, RBX is equal to so, ilipat natin sa right side ng equation, 6 sine of 60. So, that is 5.196 kilonewtons. Okay, and to solve for RBY, let's apply yung third condition of equilibrium. Summation of forces along the vertical axis is equal to 0. So upward forces, positive. Ay, hindi na pala nakikita. Sorry. Alay ko na lang dito sa mga ibang part. So summation of forces along the vertical axis is equal to 0. Upward forces, positive. So ano yung mga upward forces natin, lahat ng vertical forces natin? RBY, we have assumed it to be upwards. So RBY. Ano pa? RA is also upwards. So plus 8. And then we have the 10 kilonewton force downwards, so minus 10. And then we have Fy to be downwards, minus 6 cosine of 60. Meron pa ba? Wala na. So, equate that to 0. So, RBY is equal to 5 kilonewtons. Okay? So, that's it. So, we have solved now for the reactions. So, we'll continue solving other problems sa next videos na lang.